morning. Let me just get my timer up real quick. Okay, great. I'm Mark Einfeld, as you can see. I'm teaching many of the networking classes here. I'll give you a little more background about myself in just a moment, but glad that you made it. Whether you're new to IT or you've been in the field for a while, I know you'll get a lot out of it. Really, there's a lot of great hands-on stuff going on in the afternoon, as well as, again, what we're talking about this morning. Background about myself, I've worked in the field for a number of years. I worked at a health center in Philadelphia for 5 years, 3 years of the 5 years. During that time, we migrated from a Microsoft workgroup to a Microsoft Active Directory domain. We built thin client computers, literally out of a mini ITX board, bought all the parts from Logic Supply, an online vendor, and built them because we needed to save money because we were a nonprofit community health center. So I've done a lot of fun things. I'd throw in there, we also migrated from paper charts to an electronic medical record system, and that was certainly a doozy. And as any big IT project goes, you phase it out and you keep testing and monitoring and tweaking things. I've earned various industry certifications. I'm a big proponent of that, A+, Net+, some Cisco certs, CCENT, CCNA, CCAI. They are critical for your potential advancement in IT, coupled with degrees. I've taught for 5 years now at some of the local community colleges. I've worked at Lake Washington Institute of Technology for 4 years. And last year I started working at Edmonds, and I'll be teaching here for the foreseeable future. I've also taught a few classes at Cascadia as well. So I've done enough of that. I love teaching. I've actually taught elementary and high school as well. So that's a bit about me, other than the fact that I love this field. I love the fact that I get to be constantly challenged. I get to learn new things. I get to try and solve problems or figure things out. And so if that resonates with you, you certainly came to the right field, the right seminar today, conference today, because that's really what it is. If you talk to anybody else you're in the field, you realize, I got to keep learning, I got to keep up, I got to keep doing, I got to learn more, I got to figure things out, I'm going to try things out at home. When I worked at the health center, I would take projects home and work on scripting to make sure that when the users logged in, they could see their shared drives and their individual links to websites. And I did that at home just because I wanted to do more for IT there. So that's a bit about myself. I do have a master's because, again, I'm always learning. Let me continue on. All right. We're going to segue now into networking. And so I have a video clip. Before we start it, I do want to give you a little background. This clip's taken from the IT Crowd, a BBC show that's been out for some time. It's called the IT Crowd because it follows the 3 that are in an IT office or IT department, and 2 of them, Moss and Roy, are trying to pull one over on one of their peers simply because they felt like that peer was getting, a little too arrogant, a little too big for their britches. So we'll watch that clip and then we'll jump into networking.
What is it?
This, Jen, is the internet.
What?
That's right.
This is the internet. The whole internet.
Yep. I asked for a loan of it so that you could use it in your speech.
It's so small.
That's one of the surprising things about it.
Hang on. It doesn't have any wires or anything.
It's wireless.
Oh, yes, everything's wireless nowadays, isn't it? So I can really use it in my speech. What if someone needs it?
Oh, no. People will still be able to go online and everything. It'll still work.
Oh, good.
I tell you, you present this to the shareholders and you will get quite a response.
Can I touch it? Ooh. It's so light.
Of course it is, Jen. The internet doesn't weigh anything.
No, of course it doesn't.
Hey! What is Jen doing with the internet?
Ma said I could use it for my speech.
Are you insane? What if she drops it?
I won't drop it. I'll look after it.
No, Jen. No, this needs to go straight back to Big Ben.
Big Ben?
Yeah. It goes on top of Big Ben. That's where you get the best reception.
Roy, I promise I won't let anything happen to it.
No, Jen, I'm sorry, but the elders of the internet would never stand for it.
No, Roy, I spoke to the elders of the internet not 1 hour ago. I told them about Jen winning Employee of the Month, and they were so impressed that they wanted to do whatever they could to help.
Wait a minute. The elders of the internet. The elders of the internet know who I am. You've got to let me have
No, Jen, I'm sorry. It's just too risky.
it. Oh, please, Roy.
Oh, well, Moss, has it been completely demagnetized?
By Stephen Hawking himself. Who sent his congratulations, by the way.
Well, if it's okay with the hawk,
So, can I have it?
you can.
Oh, don't forget your speech.
Oh, thank you.
Slowly.
All right, I like to play that one. It's a good segue or transition into networking, a fun one. There we go. To begin with networking, if you're not familiar, talk a little bit about the history of networking. On the eves of Sputnik being launched in 1957, the United States and the Department of Defense came up with the Advanced Research Projects Agency, known as ARPA. Also has flip-flopped between ARPA and DARPA over the years, the names, but needless to say, that same agency. And they did so because they wanted to prevent any further technological surprise. They didn't want to be caught unawares, caught not knowing that, hey, there's other technology out there that could do more, could be more, could, again, benefit more. And so, obviously, again, DoD came up with ARPA. And years into that, into the late 60s and early 70s, the TCP/IP protocol stack was created. And the importance with this is that this particular protocol stack created universal computer communication. It really is kind of this open source set of protocols that's used, like the lingua franca, like this language that can be used between all kinds of devices in order to make sure that everybody's on the same page and talking again, in the same manner with the same IP address type protocols and things of that nature. So this was really revolutionary. One of the first tests that was ever done was between UCLA and Stanford. So if you're looking up here on the screen at the bottom there's a circle for UCLA. I know it's a little bit hard to see, but that bottom particular circle is where Len Kleinreich and his crew were attempting to log in from that device to, let me see if I can point to, there you go, right there. Point to connecting into Stanford Research Institute, SRI. And the goal, again, was to log in from one machine to another, to now connect to individual campuses and computers to each other. And the first transmission was the attempt to type in the word login, because you'd need to type login and then user account, password, things like that. And they typed in LO, and the thing crashed. But that was the first actual connection point. And as Len Kleinrock says, I'll show you a picture of him. This is him standing next to that routing switching device. As he says, lo and behold, typed low, got that far, and that was progress. And this is really significant when we're talking about late 60s, early 70s now, going, that's 40 years ago. That's not a long time back, at least. The device he's standing next to takes up like an entire closet. You open the door and you've got literally like computer blades that are the computer power to make this work. It is a routing switch device that is going to forward traffic, obviously in this case, up to Stanford. So very fascinating, and again, one of the first major kind of movement devices, interconnectivity devices in networking. So Len with the IMP, the interface message processor. When it comes to networking, it's helpful to think about what life was like before networking and then obviously after. And for me, I grew up, I had a Commodore 64. Anybody ever have a Commodore 64? A few of us? I had that originally, literally the whole computer was within the keyboard, and I plugged in cartridges, played some games, and then later my parents bought the floppy disk drive, and I got a 5.25-inch disc, put it in the disk drive, and I played games. My point with all of that is, with the Commodore 64, I literally was all by my lonesome. Me, myself, and I played games by myself on the computer, math games, some sort of Winter Olympics we had. We graduated to the i386. The same thing took place. I've got a nice computer. I literally put a disk in, whatever game I'm going to play. I have to navigate to the drive within the command prompt. I want to go to D drive. I type start or I type run, and I play my game. I don't have any interaction with the outside world. My PC is an island. And it's just helpful to think about that because for some of us who are younger, I'm pushing 40, so I'm a little bit older, but for those of you who are younger, you might not have grown up with computers that weren't networked. I mean, I remember using the i386, trying every game possible on Microsoft 3.1 because I was bored. I played Minesweeper too much. I played, what else was on there? I'm trying to think, Mahjong, all these different games, and it's like, okay, I'm done. I did it all. So that was life before that. The only connection I can make for you, perhaps, is if you have a cell phone and you're traveling and you don't get connection, some of us kind of get bored and go, this stinks. I'm not getting my tweets. I'm not getting my Facebook updates. And so what do some of us do? We start to toggle through old text messages and delete them, or go through contacts and delete people we haven't talked to in a while. Really, that's what it's like before networking. Obviously, we live in this day and age now where networking is here. It's here to stay. The internet itself is the internetwork, and I call that the network to rule them all, for good or for bad. The idea that, hey, we're all connected devices that can communicate to each other. And so now we have this massive kind of worldwide infrastructure that utilizes transoceanic fiber optic lines, that uses satellite connections. If you didn't know, when the tsunami hit, 10 years ago, 11 years ago in Indonesia, in that area, internet was knocked out for a day. But within a day, because of satellite connections, all of a sudden you have connections that are up and running. So in this day and age, it really is easy to get everybody connected, even if there are lulls. The relevance, obviously, when it comes to networking, a lot of devices now are connected. You can see PCs, servers, laptops, tablets, cell phones, household appliances. Anybody have a Nest? Thermostat? My brother has one. My brother-in-law has one. We're vacationing this summer with my brother-in-law and his family. They're up from Southern California. He had friends that were staying at his house. He literally pulls up his iPhone and says, our friends are there. How does he know that? Well, he's got an app that speaks to his household appliance, his Nest thermostat, and he lives in Southern California, so he keeps the temperature high when he's gone, doesn't want to run AC, and all of a sudden he goes, temperature's at 72, it's no longer at 80, whatever he left it at. They're there. And kind of lo and behold, okay, there it's happening. The benefits are that you can see e-commerce. Many of us have bought things from Amazon. Managing appliances in real time. I had a friend who used to manage a water ice, kind of like a slushy, slurpy type place on the East Coast in New Jersey. He'd pull up his iPhone to watch video footage from a security camera because he needs to make sure that no one is taking money from the till that shouldn't be. So really, it's amazing at how far we've come with networking. I put healthcare up there. My wife and I typically check our healthcare website, Group Health, check for kids' shots. I mean, there's so much that we can do that is now at our fingertips. And you can see stock trading and also college courses. Our college courses, a lot of the content is online. So it's remarkable what's going on. As we go through this, please be welcome to ask questions if something sticks out. With networking, I do want to break it down for you. If you're new to networking, you have routers that move or route traffic between different networks. And I'll talk about networks and how we define that in just a moment. But the idea is we're moving between individual zip codes. So that's a good example to hold on to. When you think about networking, it's like our postal system and our address system here that we have in the States. You're moving traffic from one network, one zip code, to another, and perhaps through many zip codes to get to your end destination or end zip code. So when you hear the word router in the most traditional sense, that refers to a device that's going to move your traffic between different zones, between different networks. If we're again using the traditional definition of switches, a switch will switch traffic in the same network. So right now we're in the zip code 98036. So you could say, okay, well, we're just moving traffic, moving snail mail within that same zip code. And then obviously we have end user devices that are going to be sending these messages to whomever they want to talk to. And again, it could be from tablet to server. It could be from phone to phone. I mentioned security cameras. We have wireless phones. There's so many things that are connected in this day and age. Game consoles, again, we have to send what we're playing to all the other users out there because they're joining us, again, for some particular online game that we're all a part of. All right, so let's kind of bring this back to kind of a bigger picture understanding. We have networking. This is good. Our computers are networked. We get connected. Again, whether it's for the household appliance purpose or I want to go do research on the internet. I was down in Oregon last week. I want to research the best, restaurant to go to. Okay, run over to Yelp or TripAdvisor and figure that out based on reviews. I can do that. I've got a phone. I've got cell phone connection. Awesome. But the real question now is, what does that really look like? And I've already mentioned to you, the computer world, and specifically networking, does have something like the postal system, where we have like a zip code and we have a specific address. Now, it's different within the computer world and the networking world because we have something called a network address and a host address. And the idea is those values go together and they show up as an IPv4 address. So most of us who have ever had to call into our ISP, they probably have taken you to the NIC's properties and you might have had to change them or set it back to dynamic, but at least we have values there, IPv4 protocol, that's going to do that for us. And again, the mask that's used with that address will separate the network portion from the host portion. So I'll show you in a moment, but most of us on our home networks are 192.168.1.0. That particular network, again, if you've ever looked at your computer settings, and the first three values would be your network address, and that final value would be your host address. And again, the analogy that I use often would be, it's like having a house that is, aim up here. There we go. It's like having a house where I live in Linwood, I live in 98037, and I live off of Maple Street, and I have a zip code that's very generic. It's like a zone that I'm a part of, but then I have a specific address. Like, I have an individual value that's a part of that general zone that I'm inside of. And if I want to send something to the 98036 zip code, where this college is, I'm going to send to that zip code and also have a particular address, like the college's address, 20,000 West 68th Avenue West. So I have that kind of a logic now that I'm aware of, that you can kind of hang on to or kind of anchor your mind into and go, okay, I've got zip codes and I have addresses. Computers do the same thing. They do so via their NIC, their network interface card. The network interface card, it's a transceiver. It can send and receive. It can upload things. It can download things. Those words mean the same thing, that, hey, I could create a message and send it out, and I'm going to follow the right rules, use IPv4 or maybe IPv6 if the network's set up for that or configured for that. But if I follow those rules and everybody else follows those rules, it all works. We're all speaking that same language. I mean, I don't know if you've ever heard of the language Esperanto, maybe some of us. But years ago, there was this effort to create a universal language, again, throughout the entire world. Didn't obviously succeed, but that has succeeded with networking and TCP/IP. All right, let's continue. Oh, I'm aiming the wrong way, my bad. All right, your main perhaps exposure to networking, if you're brand new to the field, is this diagram right here. You've got a laptop at home, you've got a desktop. Your desktop is hardwired into a router. The laptop is connecting wirelessly to your wireless router before you connect into a modem. And some of you might say, well, Mark, actually my setup, the two devices are fused into one. That's becoming more standard now. Frontier does that for me. I've seen that with Comcast can do that for you as well. But the big picture here is you have a wireless router that's operating as a router. It's moving traffic between this network right here, that's to the right of the router. Everybody's on that one local area network, the 192.168.1.0 network. And again, those first three numbers, they correlate to here's your mask. And so those first three numbers are going to be your network portion, your zip code. And then that last field, that last octet, will have a specific number in there, and that's your specific house address or your computer's network address, the host address portion. But most of us have this, and the router itself is a switch and a router. It's actually both. There could be between 4 and 8 ports on the back. You plug your connections in, and your router can do both, ultimately connecting to the modem, to the ISP. Anybody know what the purpose of the modem is for? Anybody? Is there one? Yep, go for it. Good. It is translating. What are we translating from and then to? We're translating from a digital signal. Our computers, they're all using digital signaling. They're sending our ones and zeros in discrete values of, hey, positive voltage, no voltage. It's very structured, organized. It can be really controlled or regulated. That's all digital to the right. But when we jump through a modem, as we've heard from a couple people say, look, hey, this is digital, but now we're jumping on a different kind of highway with different kinds of rules. And those rules connecting into the modem would be, hey, it's a phone line. Hey, it's a coax cable line. And so those particular forms of cabling and the devices that are connected to them, they're using analog signal. So they have some sort of wave that's being used to communicate ones and zeros. Because the goal is no different from writing a particular message and sending it via paper, snail mail, obviously through the postal system. We do the same thing with computers. We create a message. Hey, we send an email, or I'm going to go online to check my bank account. I have to create that message, formulate that in ones and zeros, organize it, and send it out. And obviously those are going to be sent out with different voltage patterns. And obviously through the modem, we're going to translate into an analog signal. So good work. And obviously then at some point, we're going to reach the ISP. In this particular image, you've got one network here. And if you didn't know, your wireless router, again, has a bunch of switch ports on the back, but it also has an internet port. It has a WAN port. And the purpose of that now is, here's one network over here. This internet or WAN port, it's going to have an address. It's going to obtain an IP address from your provider. You're now looking at, here's one network. Here's another network. And so now all of a sudden we have, here's a private network. It's a private zip code, you could say. And all of a sudden, the way I get connected to the rest of the world is I now have to go through my ISP. And by the way, I'm going through a particular network there. What I'm going to be talking about today, in my afternoon session is this particular diagram here. You're going to build that. You'll build that in a simulation software. If you're looking at this with me, to the left, you've got a router, a switch, and a PC. And from this interface and down, that's one network. The network, if you can see here, is 192.168.1, and then .0 is that network value. So everybody over here is in one network. The routers have to talk to each other in a network. And so they're a part of the 192.168.1.2.0 network. And then obviously we have a third network over to the right, and that's the 192.168.3.0 network. The big picture here is you could easily say, oh, that's network A, network B, and network C. Okay, good. Now, computers aren't going to do that. They're not going to use lettering. They're going to use binary. They're going to use IPv4 addresses. So they're going to think about it a little bit differently. But the big picture is there's differentiation. This network is different from this network, which is different from this network. Has anybody ever done a trace route on your home computer? A couple of us. So for the rest of us who have computers, I don't have it up here, but trace RT is the command. If you go to your command prompt and you type trace RT and you then space and type google.com, that little program will send little pings out to find the path through different networks that you take to get to the other side. And again, it's no different than if we compare it to our postal system. We put a letter in the mailbox, the local postal worker picks it up, brings it back to that particular office that we're a part of in our zip code, and eventually that particular letter could be driven or flown through or across different zip codes. Traceroute will show you that. Hey, I stepped from one network to the next one, to the next one, to the next one, until I got to my intended destination. It really is remarkable. I mean, I've worked small business. Apart from those years at the health center, I worked for a remote network startup company. And so we were doing remote network management, managing clients. I was in Philadelphia managing clients in Staten Island, Northeast Philadelphia, outside of Philadelphia. And I remember one time we're driving up from North Philly, and my partner Steven says, look, Mark, I just got a call from the health center. They're having problems connecting to the electronic medical records system. Could you log in from my iPhone and check? So we used Log Me In. It's a remote product that you can use. We used to use that all the time. Log in, use his smartphone to do that, the iPhone, check the server that the EMR is running off of. Oh, the database, IBM's DB2, wasn't running. The service wasn't working. And so right then and there, as we're driving up Roosevelt Boulevard, oh, go to my services, turn on the service, quick call them. Do you have connection to your electronic medical record system or electronic health record system? Yes, we do. Thank you. Now, obviously, we want to find out why the service stopped. That's not for discussion for them now. It'll be for later once we solve it. But obviously, make sure everything's working correctly. I traveled with my iPhone, or Stephen's iPhone, my bad, through different networks to get to the network that was on Staten Island to then send the message to the computer, hey, enable or turn on that service. And all from, again, the touch of a phone. It is exciting and perhaps even a little scary. I mean, we've heard there are networked cars now. I recently read something about a test that was done to try and hack a Jeep Cherokee. Anybody read about any of this? It's a little concerning. The article starts out, because there's one friend testing, the other friend driving. Hey, I'm driving the car, and all of a sudden I notice the heat turn on, because the hacker, their friend, is turning on the heat. Then he turns it off. Then the hacker turns on the blinker. And then that goes off, and then the radio goes up, and it goes down. Again, all of this is possible because we have a universal networking language, because we're all connected via wires or wireless, satellite. That's all happening. And then because one person can compromise another, again, this was all done in, not fun, but as a test. And so that doesn't sound very harmful, but then move on to, okay, that's okay, the driver's saying, but all of a sudden then my transmission starts switching from drive to third to second. That's not a good thing. Or my brakes all of a sudden were applied. So there obviously are the good and the bad with networking, but all of that takes place because we're moving our traffic from one network to another. The project that we're working on in the afternoon session is this, and here is the software now. It looks slightly different, but again, you still see the three networks. When you see a router, think that a router will separate different networks, and they do. The router's up top here. This one separates, here's a network here versus that one, here's a network here versus that one. So 3 networks again. The simulation software allows you to drag and drop different devices, different objects on there that can do different things. You'll configure them with the right values. You'll configure the routers. You have to essentially either program or teach the routers to learn about the other networks, because the routers need to have intelligence to move traffic from one network to another. They don't just do that by themselves. They have to be taught or programmed or configured to do that, either statically or dynamically. The picture up here is simply the printout, you could say, for some of the settings. If you're doing the settings from the command line, if you come to our college and you're taking Cisco classes, you're doing that entirely from the command line, and you need to kind of double check, what settings did I give? Oh, well, I gave these settings right here. This is my interface, fast Ethernet 00. I gave it the right IP address, the right mask. What about, okay, I did set up RIP, which is this dynamic routing protocol that essentially allows routers to talk to each other, to teach each other about the networks that exist. So you'll be building that. Again, 45-minute session. I do have models that are entirely built, if you want to look at that. I have models that are half built. We will try and build the whole thing for that particular block. If you've never done it before, it really is a good foray into, okay, I'm getting used to this networking thing, and my traffic does move between zones, between networks, and now I can see how it kind of works with, again, different devices. It really helps you kind of put the basics together. When it comes to, again, what we do here at the college in terms of content, we talk about the theory first. So you can see the OSI and TCP IP networking models. Those are models to describe the order of the information that we put in our packets. We speak English, or perhaps many of us speak different languages. So whether I'm speaking English or Spanish, there's certain syntax. Porque yo puedo hablar la lengua también un poco. But so when we're speaking a particular language, we have to follow certain rules, certain order, certain syntax, we would say. The same is true in networking. We need to know the theory, because the theory actually gives us a real model that says, I use this protocol, the Ethernet 2 protocol, I use the IPv4 protocol, I use TCP protocol, and I also use maybe my HTTP protocol, because I'm logging in. I have to use the right protocols in the right order, following the right rules to make it all work. And again, if I use that language analogy, if you're not using the right syntax, because I sometimes just muck it up when I'm speaking Spanish, I was in Costa Rica, and I certainly could ask, necesito las direcciones a la playa. I could ask basic questions, but sometimes I couldn't conjugate. I couldn't do it as well as I needed to, and I just get blank looks because what I'm saying doesn't make sense. And the same thing is true in computing. You have to have adherence to this absolute syntax so that one computer, when it talks to the other, knows how to interpret that communication. So we go through theory first, and obviously then talk about routing, forwarding, switching logic. Why do the switches switch or move traffic a certain way? Why do routers move traffic from one network to the other? How do they learn that? We have to kind of cover that. And then we actually configure the devices in various labs. The classes we offer that are Cisco specific for networking, which is primarily our networking block, would be 171 through 174. And there is really a graduation between this entry-level Cisco cert right here. This is that entry-level one, that after covering 2 classes, you've covered most of the material that you would need towards that CCENT. And then obviously the next 2 courses would round out the remainder of the Cisco certification. The classes themselves, if I'm looking at that with you, this is basic networking, so theory and basic programming of switches and routers. Moving on to more of an intermediate focus on networking and getting into more intermediate features of switches and routers. So VLAN, static routing, dynamic routing with RIP and OSPF, a little bit of NAT there too. You have to translate traffic sometimes between a private network and a public network. With the remaining classes, this really is this advanced networking class where you're covering any last critical detail. I need to know OSPF because my new company, the enterprise that I'm going to work for, it's using OSPF. That's a dynamic routing program, dynamic routing language, a protocol that's used again so routers can talk to each other. Well, we'll cover that here as well. ACLs are in between 172, 173, 172, and obviously you use them then 173. And then we round out with 174 looking at more of the WAN issues. If I build a network, and I build a network for a medium-sized organization, 200, 300, 400 people, and I now know how it works, and I put the right IP addresses, I did the right masks, I have my right zones, my right networks, and I connect them with the right cables, and I know how to manage DHCP, or I know how to do ACLs, or do a few other features. Once I do all of that, I still need to think about what happens when I connect to the outside world? What happens if I need to connect to another site? I need to make a wide area network connection. I need to connect to a satellite site. That's what we had to do at the health center in Philadelphia. Hey, we're going to pay for a T1 connection. We'll talk about that. We have to set up a point-to-point protocol connection. I need to set up frame relay, and we can go through that broadband cable connection. All of that would be in that final class, as well as a couple other pieces. When it comes to networking, we are, again, a partner with the Cisco Networking Academy, so you do have access to the different software that's there. When it comes to that, let's talk about, I'm aiming the wrong way again, still getting used to my surroundings. There we go. The degrees that we do offer that are network specific would be the first, the networking technology, ATA. That is specific towards LAN, WAN, interaction, communication, including servers, desktop. So we work with Steve Higdon going from desktop to me networking to Bill servers, throwing a little bit of security as well there on the side. So that's that networking technology degree. There is a generic one, CIS ATA, very generic if you're not sure what you're going to do. As Steve Haley mentioned earlier, there are certificates offered, 44 credits. So it's like going from a 2-year degree to a 1-year degree if you want to think about it in that terms. There's also, and that's specific to networking as well. There's also a certificate of completion, which is like saying going from 2 years to 1 year to now 1 quarter's worth of classes, about 15 credits for that particular degree. And you can check that out online as well. But again, if that interests you, it's always good to keep learning. I'm still reading through books. I read through a book and a quarter this summer, so that's there. When it comes to Cisco, I'll kind of wrap up with this. The job possibilities are great. I logged into LinkedIn yesterday just to pull up, if I typed CCNA in there in the Seattle area, and I know it says 50 miles, but all these jobs are Seattle up to Everett. There's 79 jobs just right then and there. CCNA, if you're looking at CCNA and you work towards that, let me give you just a basic salary comparison. And these numbers prove to be pretty true. I have taught for a number of years. I ask students kindly, hey, mind telling me ballpark what you make? because I'd like to tell other students what the job market really is like. Because it's not fun, it's not good to, I don't know, be kind of hoodwinked or kind of sold something, a non-truth, an untruth, where I'm going to make a lot of money. No, I typically say you're going to make between $35,000 to $80,000 if you go through a 2-year degree and get certs, and that's over maybe a 10-year lifespan. That's what I've kind of gathered from asking people, and this kind of confirms that. Hey, you get a Cisco degree, a CCNA, so after those 2 tests, you suddenly hope to perhaps get in that $45,000 range. I've had students, after a couple of years, jump up to 60s. I've had students even jump up to 6 figures when they were done IT and for about 3 years, but they were, obviously certs, whizzes, they had done a lot. But that is a possibility for you. Let me wrap up with the networking piece. Networking really is everywhere. Even, I could pull up my license, I won't. I have an ARFID chip in my driver's license. I have the license, the enhanced driver's license that allows me to go back and forth to Canada or Mexico. I leave it in the magnetic sleeve because I don't want it to be scanned. Not that it could perhaps do anything of great damage to me. Mike and Steve could tell me otherwise. But everything's networked. Again, it can be a little scary. It can be very exciting. But networking really is the glue between desktop computing and server computing, which then enhances what the others will talk about. Hey, security. Now that you have computers, or I should say nodes or devices that can connect to anybody, anywhere, anytime, and I mean that. I had friends who used to, again, log in from a cafe to home and then run some sort of text-to-speech program to scare his wife. Hey, honey, I'm home, and the computer says that, and he's still at the coffee shop. I mean, you can do anything. We've heard the crazy stories and the exciting stories, but really networking is that interconnecting glue that puts it all together, that enhances IT, and also, again, creates newer realms of IT for security and critical kind of analysis. All right, let me wrap up. With that being said, are there any questions with what's been covered in, and we'll get there, here we go, in networking, or also programs, classes that the college has to offer? Is there one? Yes?
Will we hear from Steve about the job opportunities for the digital forensic cybersecurity side?
Yes. Yes.
Okay.
Yeah, I don't have quite the nice charts and so forth like he does, but we will certainly talk about it.
Oh, I don't know.
Yeah. Matter of fact, I've got a couple of one of the students that was checking people in, Kyle. He just landed his first digital forensics contract job, and so maybe I'll have him go ahead and talk about that and give a few words. Yeah.
Good. Other questions? It's a little hard to see.
Right here.
Yes.
Do you have statistics on job clearance rate? So from students going from graduation to their first gig, do you have stats on that?
Good question. We haven't been tallying that specifically. I ask my students. Really, what it boils down to is if students are working hard, and I mean that. There are students who work hard versus students who are kind of coming to class and kind of doing work. There's a difference between what they're learning, but the students who work hard, more often than not, they're getting gigs, they're landing opportunities. Again, just talking to a student, they had taken a lot of the classes. They were talking with someone from one of the networking companies around here, and they were asking them, well, what do you know about networking? And they told them A, B, C, D, all the way to X, Y, Z, and they said, hey, I'd like to like to give you an interview. So the what I can tell you is, like from Lake Washington to even here, the students that work hard, that might work towards a cert or a couple certs, you have a very good opportunity of really getting your foot in the door, even with little background. Because again, that's the bigger challenge. It's not those of us who have worked a couple years that have it on the resume. It's getting that first interview to get in, because that could be challenging. And so if you have, like I had a student who had 5 certs and the degree from Lake Washington, same kind of degree here, the networking one, they ended up getting a contract job with Microsoft, and after a couple years, they finally got the full-time at Microsoft. So, although I can't give specifics, I can give a lot of success stories for that. Before we take the next question, I do want to say, all of us here are committed to your success. If you do come here, we're in your corner for you to challenge you, to push you to work hard, to learn the content. I mean, I'm going to be behind students who aren't working hard, and I'll have those hard conversations. I had them last year. Hey, so-and-so, you're really capable, but you're just not pulling your weight. You're not doing it. You're not seeing your potential. And lo and behold, the student wisens up a bit, takes the final and aces the final, the practicum. And I thought, yes, I mean, that's what I get excited about when you take control of what you want to do and you put the time in and you really put the blood, sweat, and tears. And it's not easy. It's blood, sweat, and tears, but you do the work and all of a sudden you get the stories of, wow, this success story, that success story, because they did it.
I'm actually one of those successful stories, so hello, instructors. I'm back. No, after I graduated, I did all the classes. I got all the certificates and all the other things I forgot. But it took me probably about 6 months. But in the beginning, the first couple months, I was just kind of laying low because we studied a lot. So I was just kind of burned out. So then I started, talking to people and stuff like that. And how I got my recent job is a guy overheard me talking about some stuff, and he works at Snohomish County. So I've been up there doing phone extractions. So and that's been pretty interesting. I don't know if you guys saw the story just this past week on Como 4. They were running a story, and actually I was in that little clip, all the wasted money that taxpayers are doing. So, well, it kind of created a job, but after I heard about that story, I didn't know about a lot of other things, but it was very interesting. But I just want to thank all my instructors down there. So, from networking, pulling out RAM from basic PCs to learning forensics. Thank you.
Thank you. To piggyback on what he just said, if that is a little daunting to hear, okay, it could take a little bit. If you're in the category where you don't have any networking experience, any computing experience, security, any of that, and you go through the program, what's critical is that you're talking with some of us to go map out a plan. I got to set up my LinkedIn account. I've got to scour or connect with all my connections, whether it's their teachers or family members, because it's all about, again, getting that first interview. And so putting portfolios online and on LinkedIn. I had students put videos up, and they would put their final 50-page project up from the last college and really helped get a job at Google or helped get a job again through one of these companies that was contracting with Microsoft. If you're doing all of that, that's really what can help put you in the best light to kind of make those connections to get that first interview and that first job. Any other questions? Okay, I think we're good, so I will hand it off. Thank you again, and feel free to ask me any questions during breaks, during session. I'll be at the networking design session. Thank you.